Hey everyone, welcome to a stream where I'm going to show off some of the work I've been doing this morning on how to use pandas data frames inside of Ibis. This is a new feature. As you can see, I'm on a branch, table literal data frames, which is where this work is, and it's not yet in a pull request. I'm going to pull request it later today or tomorrow. So with that, let's get started. I'm going to fire up IPython, clear the terminal, and let's import Ibis. Okay, let's import pandas because, like I said, we're going to show how to construct Ibis expressions that involve pandas data frames with basically no additional kind of infrastructure needed on the part of the user to use them. We'll connect to our the DuckDB backend using our trusty TPCH data. If you're not familiar with TPCH data, I will post a link to that in the chat. The TPCH is a benchmark standards body, and a lot of people benchmark various things against them. DuckDB happens to have a pretty nice way of creating this data, and I made one on disk earlier. So we'll connect to that, and we can see that there's a bunch of tables in there. You can see I've been kind of tinkering around with various things, T and foo, and sort of, there's custs and election subset, and I've kind of been tinkering around with various things and haven't really, cleaned stuff up. One thing we can do is create a new database, but for the purposes of this, I think I'm going to just leave it as is. The things we care about, I think in this case, are some of the other tables: part sub, line item, orders, and sort of the data here are designed to be kind of business intelligence-ish, related. And so it's kind of a database of like customers and what parts they're ordering, and where those customers are in the world, and who's the supplier of the part, and etc. So the thing I'm going to kind of show how to do is like compute the number of customers per region. And so let's to that let's set Ibis interactive, Ibis options interactive to true, and pull out just the customer table. So a new feature that'll be showing up in I think it's in 3.2, it might be in 3.1, but it's this tables accessor object, which lets you sort of see what's in the table with tab completion. So you'd say customer, and now we can look at customer. So let's see like the head of that. And so so we've got a bunch of columns and so forth, and you see there's this column here, nation key, and that's kind of what we're interested in. You might be like, oh, well, is there a region key that we can look at? And it's like, well, C region key, and it's like, is that a column? It's like, it's not a column. So we're gonna have to actually do like a two-way join, because it's not. We can get the region from the nation, but we can't get the region directly from the customer table. So let's pull out the nation table and take a look at that. This table is pretty simple, right? It's got 20, or it's pretty small. It's got a subset of the many countries in the world and some generated fake comments about them, and then the region that they correspond to, and then a nation key that's the primary key of the table. What if our region table, so we also have a region table in the database that we could do all of this through, and then we wouldn't need to deal with pandas at all. But for the purposes of the tutorial, I am going to construct like this table in memory using using pandas. So now we have region. It's like a proper data frame. It like doesn't just look like one. And so kind of the way you would express this, let's actually express it with the expression-based region first. Right, so that's like an Ibis table expression. And the way you would kind of express this is like you would say, customer dot, join and nation, and you can see like IPython is kind of nicely remembering what I wrote before, and you might say customer dot C nation key equals N nation key join on the region, and then say this kind of thing. And then you'd get, it kind of looks like you're only getting 10,000 rows, but this is just Ibis like not pulling back all of the data. If you were to run count on that, you'd see, okay, there's actually 15,000 rows on this thing. And so the expression we're actually after is joined.regionName.ValueCounts, which if you're familiar with pandas, will do a group by count on the column you're calling this on. And so this is kind of our result. And with this new feature in Ibis, you can actually write the same expression, but give it a pandas data frame instead. And Ibis will kind of take care of converting that into an expression and doing the right thing with the SQL. And I'll show you in a bit sort of like what the generated SQL looks like and a little bit about how it works. So we can actually just write the same expression again, and that works, right? And if we turn interactive mode off, we'll see our joined expression. We have two inner joins, and then sort of the leaf tables. And you can see there's this like funky looking table literal thing in here, and it's like, well, okay, it kind of looks funny. It's got the data, and then it's got the schema, and it's it's kind of pointing at what exactly we're going to do with the SQL. Let's turn interactive mode back on, and then we can rep or join again, right? And we've got the same thing, 10,000 rows, but actually there's 15,000. We do that again, and then we say join.rname.valueCounts, and it's actually kind of done the same exact thing. We scroll back up, we can kind of see 3036, 3005, 2977, 3014, 2968. And we see the same results down here, and I actually was able to pass just a pandas data frame in there. I didn't have to kind of create an Ibis expression from it or anything. Like Ibis sort of took care of like kind of doing the promotion to an expression. Now you might be wondering like, what in the heck is happening here, right? And so there's this fun tool that we recently added to Ibis to format SQL in a nicer way than the kind of the previous tool we were using before. It's called Sql Glot. People should check that out. It's a cool project, and I'll put a link to it in the chat. And there's like a util module in Ibis, and we have like a function called pSQL, which kind of the mnemonic is pretty SQL. And you can give an Ibis expression to that, or you can give like a SQL Alchemy compiled expression, which is what .compile will give you if the backend is SQL Alchemy. Well, let's just pass this value counts thing in. And we can see there's like group by, of course, the join. There's this funky values looking thing, and like what the heck is going on there? There's the other join, the nation key join, customer select, and then sort of the group by key and the aggregation. And what is actually happening here is that we are basically dumping the rows of the data frame into this values construct. And if you're not familiar with values, it's a lightweight way. Well, lightweight I guess is sort of relative, but you don't have to like create a file or anything like that to use this construct inside of SQL. Whether the question marks are bind parameters where you can, like we're actually giving like sort of a list of the tuples of the data frame to the SQL Alchemy compiler, and it's figuring out what to generate there based on kind of the number of tuples. There are definitely room for improvements here. Since we're using the DuckDB backend, you can actually be much more efficient with data frame execution, and you don't have to insert, a new string, row for every element. We could potentially kind of make a DuckDB view with the in-memory data, and then just query that as if it were, kind of a table in the database. that would allow you to sort of operate more efficiently on data frames, and possibly other things like we're thinking about expanding this to say like any of the useful in-memory representations, but sort of TBD on that. Anyway, that concludes this bit of the stream, or this stream. Hope you enjoyed. Come back for more.